Download this code from codegive.com, link in the description below. Dealing with the database disk image is malformed error. The dreaded database disk image is malformed error in SQLite and other database systems, is a common and frustrating problem. It indicates that the database file has become corrupted. This corruption can lead to data loss and application instability. Understanding the causes, diagnosis, and potential solutions is crucial for any developer working with persistent data storage. This tutorial provides a comprehensive guide to this error, covering potential causes, diagnostic techniques, and recovery strategies, along with code examples. Understanding the error. The database disk image is malformed error essentially means that sqlite's internal checks have determined that the database file is inconsistent or damaged. This can manifest in various ways. Unable to open the database. The database connection fails completely, preventing access. Query failures. Specific queries might fail, while others succeed. Data inconsistencies. Data retrieved is incorrect or incomplete. Write errors. Attempts to insert, update, or delete data fail. 2. Common causes of database corruption. Understanding the causes can help you prevent the error from occurring in the first place. 1. Hardware problems. Disk errors. Bad sectors on the storage device, HDD, SSD, USB drive, are a prime suspect. Disk errors can randomly corrupt data. Memory issues. Faulty RAM can lead to incorrect data being written to the database file. Power outages. Sudden loss of power during a database write operation can leave the file in an incomplete or inconsistent state. Unstable network storage. Using network attached storage, NAS, or cloud storage for your SQLite database, especially if the database is accessed frequently or has high write throughput, can introduce latency and potential network glitches that can corrupt the file. SQLite is designed to be a single-user database accessed directly from a local file. 2. Software issues. Application bugs. Errors in your application code that directly manipulate the database, example incorrect SQL statements, transaction management problems, data validation issues, can lead to corruption. Operating system problems. OS level bugs, file system errors, or driver issues can interfere with database writes. Concurrent access. SQLite is generally designed for single-user access. While some limited concurrent read access is possible, concurrent write access without proper locking mechanisms will cause corruption. This is especially true if you are accessing the SQLite database from multiple processes or threads without careful coordination. Improper shutdown. If your application crashes or is forcibly terminated during a write operation, the database might not be closed properly, leading to incomplete transactions and corruption. Third-party libraries. Libraries that interact with the database, example ORMs, database wrappers, might have bugs that cause corruption. 3. File system issues. File system corruption. The file system itself might be corrupted, leading to errors when accessing or writing to the database file. Insufficient disk space. Running out of disk space during a write operation can cause the database to be truncated or partially written, resulting in corruption. 4. External factors. Malware. Malicious software can target database files. User error. Accidentally deleting or modifying the database file. 3. Diagnosing the problem. The first step is to confirm that the database is genuinely corrupted and to try to understand the extent of the problem. 1. Error message analysis. The error message itself can provide clues. For example, it might indicate a specific table or index that is affected. However, it's often a general error and doesn't pinpoint the exact location of the corruption. 2 Basic database checks **** using the sqlite command line tool ***. The sqlite3 command line tool is invaluable for inspecting and repairing SQLite databases. Check the database schema. Verify that the table structures and indexes are as expected. Run pragma integrity _check. This is a crucial command. It performs a thorough check of the database's internal consistency. It will return OK if no errors are found. If errors are found, it will list them. Run pragma quick _check. This is a faster version of integrity _check that skips some checks. It can be useful for quickly identifying major corruption. Run pragma foreign _key _check. If your database uses foreign keys, this command will verify that all foreign key constraints are satisfied. Foreign key violations can sometimes indicate corruption. 3 Code example, Python. Explanation Connect to the database. Establishes a connection to the SQLite database using sqlite3.connect. Execute pragma integrity _check. Runs the integrity check. Check results. If the result is OK, the database is, likely, healthy. If not, prints the errors reported by the integrity check. Execute pragma foreign _key _check. Checks the integrity of foreign key relationships. Error handling. Includes a try, except, finally block to handle potential database errors and ensure that the database connection is closed properly. 4 Log analysis. Examine your application logs for any errors or warnings that occurred before the database disk image is malformed. Error appeared. These logs might provide clues about the events that led to the corruption. 5 File system checks. Run file system checks, example chkdsk on Windows, fsck on Linux/Mac OS, on the storage device where the database is located. This can identify and repair file system errors that might be contributing to the problem. 6 Storage device health check. Use diagnostic tools to check the health of your hard drive or SSD. Look for signs of impending failure, such as bad sectors or smart errors. 4. Recovery strategies. The approach to recovery depends on the severity of the corruption and the availability of backups. Always make a copy of the corrupted database file before attempting any repair operations, as the repair process itself can sometimes cause further damage. 1. Using sqlite3_analyzer.exe*. This tool is included with the SQLite distribution. It is a powerful tool for analyzing and potentially repairing corrupted databases. Explanation sqlite3_analyzer.exe your_database.db repair.sql*. This command instructs sqlite3_analyzer.exe to analyze the your_database.db file and output a series of SQL statements to repair.sql. These SQL statements are designed to recreate the database schema and data from the corrupted file. If the tool encounters irreversible corruption, it will attempt to recover as much data as possible. sqlite3 recovered _database.db repair.sql*. This command creates a new, empty database file named recovered _database.db. It then executes the SQL statements from repair.sql against this new database. This effectively recreates the database structure and inserts the recovered data into the new database. 2. Dump and restore ***. Dump the database ***. Use the sqlite3 command line tool to dump the database schema and data into an SQL file. Even if the database is corrupted, you might be able to recover a significant portion of the data. Asterisk create a new database. Asterisk create a new, empty database. Asterisk restore the database. Asterisk import the SQL file into the new database. Asterisk code example, Python. Explanation asterisk. Asterisk dump underscore command asterisk creates the shell command to dump the database using sqlite3.dump. Asterisk subprocess.popen asterisk executes the shell command and captures the output, stout and str. This is a safer way to run shell commands than os.system, as it allows you to capture the output and check for errors. Asterisk cursor underscore new dot execute script, SQL underscore dump, asterisk executes the SQL commands contained in the SQL underscore dump string. Execute script is designed to handle multiple SQL statements separated by semicolons. Asterisk con underscore new dot commit, asterisk commits the changes to the new database. Asterisk limitations asterisk the dump command will skip over data that it cannot read due to corruption. You might lose some data in the process. Indexes are rebuilt during the restoration process, which can sometimes resolve minor index corruption. 3. Incremental recovery, if possible. Asterisk if you have a backup of the database that is only slightly older than the corrupted database, you might be able to incrementally recover the data that has changed since the backup. This involves comparing the corrupted database to the backup and extracting the differences, example new rows, updated rows, deleted rows. Asterisk tools like sqlite3_analyzer.exe can assist with this process. You might need to write custom scripts to perform the data extraction and merging. 4. Roll back to a backup asterisk. If you have a recent and reliable backup of the database, this is the simplest and most reliable recovery method. Simply restore the backup file to its original location. 5. Salvaging data manually asterisk. In extreme cases, where all other recovery methods fail, you might be able to salvage some data by manually inspecting the database file using a hex editor or a specialized database recovery tool. This is a complex and time-consuming process, and it's unlikely to recover all of the data. Prevention strategies. The best approach is to prevent database corruption in the first place. Here are some key strategies. 1. Regular backups asterisk. Implement a regular backup schedule for your database. The frequency of backups depends on the rate of data changes in your application. Consider using incremental backups to reduce storage space and backup time. Asterisk code example, Python, using shuttle for a simple backup. Explanation asterisk. Asterisk shuttle.copy to, db_file, backup_file, asterisk copies the database file to the backup location. Copy to preserves metadata, like timestamps. Use shuttle.copy if you don't need to preserve metadata. Asterisk os.makeDirs, backup_dir, exist_ok equals true, asterisk creates the backup directory if it doesn't exist. Exist_ok equals true prevents an error if the directory already exists. Asterisk timestamped file names asterisk uses a timestamp in the backup file name to create unique backups. 2. Proper transaction management asterisk. Always use transactions to group related database operations. This ensures that either all of the operations succeed or none of them do, preventing partial writes that can lead to corruption. Commit transactions frequently to reduce the amount of data at risk in the event of a crash. Asterisk code example, Python. Explanation asterisk. Asterisk con.execute, begin transaction, asterisk starts a new transaction. Asterisk con.commit, asterisk commits the changes made during the transaction. This makes the changes permanent. Asterisk con.rollback, asterisk rolls back the transaction if an error occurs. This undoes any changes that were made during the transaction. The database is returned to its previous state. Try, except, finally ensures that the database connection is always closed, even if an error occurs. 3. Error handling Implement robust error handling in your application code to catch database errors early. Log errors and take appropriate actions to prevent data corruption. 4. Data validation Validate data before inserting it into the database to prevent invalid or inconsistent data from being written. 5. Controlled shutdown Ensure that your application shuts down gracefully and closes the database connection properly. Avoid forcibly terminating the application during a write operation. Use signal handling, example sigterm, sigint, to catch shutdown requests and perform cleanup operations. 6. Avoid concurrent write access If you need concurrent access to the database, consider using a more robust database system, example PostgreSQL, MySQL, that is designed for concurrency. If you must use SQLite with concurrency, implement proper locking mechanisms to prevent simultaneous write access. Note sqlite's WAL, write-ahead logging, mode improves concurrency for readers, but does not eliminate the need for careful locking if you have multiple writers. 7. Hardware monitoring Monitor the health of your storage devices. Replace failing drives promptly. 8. Use a journaling mode, WAL is recommended. SQLite supports several journaling modes. The default mode, delete, can be less reliable than other options. WAL, write-ahead logging, is generally the recommended mode, as it provides better performance and concurrency, and it is more resilient to crashes. Enable WAL mode Code example, Python. 9. Use a high-quality SSD If using an SSD, invest in a reputable brand with good write endurance. Cheap SSDs are more likely to fail and cause data loss. 10. Test and monitor your application Thoroughly test your application under various conditions, including simulating crashes and power outages, to identify potential vulnerabilities that could lead to database corruption. Implement monitoring to detect unusual database behavior, such as excessive disk I/O or slow query performance. 6. Conclusion. The database disk image is malformed error is a serious issue that requires careful diagnosis and appropriate recovery strategies. By understanding the common causes of corruption, implementing preventative measures, and having a robust backup and recovery plan in place, you can significantly reduce the risk of data loss and ensure the stability of your applications. Remember that prevention is far better than cure. Proper coding practices, robust error handling, and diligent monitoring are essential for maintaining the integrity of your SQLite databases.